Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are focusing on vectors and I'm focusing on May June 2025. And from this year there are four variants. That is for P3 there is variant 31, 32, 33 and then there is 35. So I'm focusing on four questions and the topic that I'm focusing on is vectors. Let's look at the first one. It says with respect to the origin O, the points A and B have position vectors such and such. Now first of all, when you have the IJK form, make sure that you write it in the column vector form. The line L1 passes through the points A and B. So now if a line passes through A and B, I can either take A to be the fixed point, I can take B to be the fixed point, I can take AB as the direction vector, I can take BA as the direction vector. So let me write all the options. Fixed point OA, OB, direction vector AB, BA, similarly AB and BA. That means there are four options. OA, AB, that is one option. The second one is OA, BA, that's the second option. Third option, OB, AB. Fourth option, OB and BA. All of them are perfectly acceptable. Now over here, this is OA, this is OB. I found AB, which is OB minus OA. Be very careful. Sometimes people make a mistake. So that is 3, 1, 2. That means if I want to take BA, that would be -3, -1, -2. And then my habit is to choose the easier one because one of the coordinates is 0. So that is why I chose 2, 0, 4 as my fixed point and then 3, 1, 2. Doesn't make a difference if I would have chosen 5, 1, 6. That is the first thing. This is for 2 marks. Then we move to the next part. It says the line L2 has this equation 2, 1, 5. So that is 2, 1, 5 plus mu 1, 2, 3. So let me make a habit of writing it down. That is line L2. That is R is equals to 2, 1, 5 plus mu. And this is 1, 2 and 3. That means if you have used lambda before, so I have used lambda over here, then the examiner has used mu. Or maybe if that examiner has used in lambda, I would have used mu. Sometimes they use the English alphabets, that is S and T also. Show that the lines do not intersect. That is the direction vector. That is the direction vector. They are not scalar multiples, so parallel is out. Basically, they are talking about skew lines. Lines which are not parallel, do not intersect. Such lines are called skew lines. So what I do is that I expand it. That is the expanded form of line L1. I expand this thing. That is the expanded form of line L2. So yes, again, column vector is the way. Now, this is one equation. The red one, the blue one is the second equation. The green one is the third equation. So if I focus on the red one, 2 plus 3 lambda, that is equals to 2 plus mu. That is equation number 1. And then if I focus on the blue one, that is simply lambda equals to 1 plus 2 mu. That is the second equation. And then I solve simultaneously. So now when I solve simultaneously, I get the value of lambda and I get the value of this thing. So over here, that is the value of lambda and this is the value of mu. This thing is done. Now what is the third equation for? The third equation is for double checking. Does this value of lambda and mu satisfies all three equations? So I plug in the green one. So now this green equation 4 plus 2 lambda, is it equals to 5 plus 3 mu? If both sides are equal, it would intersect. Since they are not equal, therefore lambda and mu does not satisfy all three equations. Therefore the lines do not intersect. That is the conclusion of this thing. Now over here, the next one, easy part, that is find the acute angle between the directions of line L1 and L2. So line 1, this is the direction 1. Line 2, this is the direction 2. So we have this direction vector of line 1. This is the direction vector of line 2. We apply the concept of dot product, scalar product. A dot B, that is A modulus B modulus cosine of theta. So now this is the A, this is the A modulus, this is B modulus cosine theta. We multiply the I with the I, the J with the J, the K with the K, divided by the magnitude, and then I get the value of cos theta. Sometimes they ask for the angle, sometimes they ask for the cosine of the angle. Since they're asking for the angle and this was positive, of course the angle will come out to be acute. If for any reason, if this was negative, we will discard the negative sign and we will get the acute angle. So this is the first question. That is May-June 2025, variant 31. This is the first question of vectors that I've discussed. Let me move to the next one. Now this is May-June 2025, variant 32. With respect to origin O, the points A, B, C have position vectors such and such. Now it's already given in the column vector form. Find a vector equation for line through A and B. So this is OA, this is OB. Let me evaluate AB, which is OB minus OA. That comes out to be this. So I have used this thing, and out of these two, I have chosen OA to be my fixed point. No issue with that. Now what are they asking? They're asking the exact value of cosine of BAC. Now they are asking for cosine of this angle in the exact value. That means what is exact in P3? Third form is exact, pi is exact, E is exact, ln is exact, and fractions are exact. So now in order to find the angle BAC, the cosine of this, I need two vectors which are both diverging from a point. So I'm taking AB, I'm taking AC, or both converging. So BA and CA. So since I've already evaluated AB and this is the angle point, that's where the angle is being made. So now I'm choosing AC. So AC, that is OC minus OA. Double check, no harm in that. 235 minus OA, 1 negative 4 into 1 negative 4 into, this is AC. Again, scalar product. AB dot AC, AB modulus, AC modulus, cos theta, we are getting this thing. So now this 35 divided by root 35, that is 35, is basically root 35 over root 35. So therefore these two cancel and I'm getting this exact value. Okay, this thing is done. Now the next one. Hence find the exact value of cosine of the exact value of the triangle ABC, exact area actually. So now what I did is that I drew a right angle triangle. Cosine is adjacent divided by hypotenuse. I applied Pythagoras theorem. I get h, that is the height. So the height is also in the exact form. No usage of calculator whatsoever. So therefore sine theta is opposite over hypotenuse, root 24 over root 59. Area of triangle, that's half AB sine C. So now over here, basically I'm using this. I have the magnitude of this, and sine of this angle. This was the cosine of this angle. This is P1 trigonometry, of course also used in P3. And then I have the sine value. So this is half into AB into AC into sine of this thing. Now look at the working. The root 59 and the root 59 cancels out. 35 is 5 into 7. 24 is 6 into 4. So you cannot take square root of 5. You cannot take square root of 6. You cannot take square root of 7. 4 is good. Square root of 4, I have separated it out. Square root of 4 is 2. 2 divided by 2 is 1. So therefore, I'm left with root of 210 square units. That is the answer. So this was May-June 2025, variant 32, the vectors question. So now two questions are done. Let's move to the third variant, which is the third variant. That is May-June 2025, variant 33. And now let's look at this question. OA, OB, OC, it's all given. Line L passes through B and C. So same analysis. It passes through B and C. So let me evaluate BC. That is 1, -4 and 5. 1, -4 and 5. That is the direction vector. and I'm using OB as my fixed point. Again, it won't make a difference if I would have used OC. Now, the famous question that is about the foot of the perpendicular or the perpendicular distance from point to a line. So now P is the foot of the perpendicular from A to L. The coordinates of A is given. The coordinate of P is written in terms of lambda. Why? Because P is a point on the line. So for a particular value of lambda, there is a point such that if I drop a perpendicular, this angle would be 90 degrees. That's the whole meaning of the word perpendicular. So now OP is given. AP, that's OP minus OA. So this is OP, OP, OP. This is the XYZ coordinates of A. And then AP is perpendicular to the line. If AP is perpendicular to line, therefore AP dot product with direction vector of line should equal to 0. That is the knowledge that I'm applying. So 1 and 1 cancels out, that is lambda. 3 minus 2, that is 1 minus 4 lambda. Minus 2 minus 0 is negative 2 plus 5 lambda. Dot product with 1, negative 4 and 5. Now, for example, if someone would have used the opposite, minus 1, positive 4, negative 5, and the whole working is written based upon this, then you are supposed to use whatever direction vector that you have used. Yes, you have the liberty, you have the freedom to choose anything as the direction vector, but once something is chosen, just stick with that. So that will continue throughout. So now you get a value of lambda that is 1/3. Since they are only asking for the foot of the perpendicular, the position vector, so plug lambda where it belongs. So lambda belongs over here, that is this thing, this is lambda. Lambda is 1/3, this is lambda, this is lambda, so it all belongs over here, that is OP. And maybe if they would have asked you for the distance, so you would have plugged in lambda over here, actually over here, simplified it, and then find the magnitude of AP. Of course, you can also find OP, you already have OA, then find AP, that is perfectly acceptable. Now, alternatively, what have I done? I have found another equation. This thing is this one, which is 1, negative 4 and 5, that is BC. So this one, it's still BC, but over here, instead of 1, 2 and 0, actually this is BC, so I have used C, that is 2, negative 1 and 3, so I have used OC. So basically OC plus mu times BC, that is the equation of the line I have used. I have used this thing BC over here, but 1, 3 and negative 2, that is OB, and I have used with lambda. Now, why am I doing it? Because a lot of people, they are confused. What if I choose this? What if I choose this? Will my answer be marked wrong? Of course not. Of course, the intermediate value would be different, lambda would be different, mu would be different, and that is what we will see over here. So now let's find OP. That's the extended form. That is AP. That's the simplified version. AP dot direction vector of the line equals to 0, and mu comes out to be minus 2/3. Over here, lambda came out to be positive 1/3. Mu came out to be minus 2/3. When we plug in this value of mu over here, so that is mu. So we are plugging in mu. Yes, the final answer, it's all the same. The final answer, it's all the same. So that is, I want to remove that fear from your head so that you are comfortable in doing by any which way. Let's move on to this one. Now it says a very nice question. Now it says the point D is a reflection of A and L. So this is P is a point on the line. This was perpendicular, keep that in mind. And now it's a reflection. So now remember, when we talk about this basic concept of reflection, that is there in O-level maths, that is there in ASP1, that is now here in A2, P3. So basically, it's the concept of perpendicular bisector. So now, if this is a reflection of this, then this line is the perpendicular bisector. In other words, P is the midpoint of A and D. In other words, P is the midpoint of A and D. So they have not labeled any point as D. They are calling this as D, and that is the working over here. So now this is OA 1, 2, 0. OD, XYZ, OP, 4/3, 5/3, negative 1/3. Take the red, the average is 4/3. Red, average, 4/3. Blue, average, 5/3. Blue, average, 5/3. Green, average, negative 1/3. That is what you see over here. Hence, you find the coordinates, and this is OD over here. This is the position vector. Let's say if they would have asked for the coordinates, so I would write it horizontally, 5/3, 4/3, negative 2/3. This is coordinate. This is PV, position vector. So this is May, June 2025, variant 33. 3 questions are done. Let's move to the fourth one. So the fourth one is this, May, June 2025, variant 35, the vectors question over here. Now it says, with respect to origin O, the points A, B, C have position vectors such and such respectively. Now it's about magnitude. It is given that magnitude of AB and magnitude of BC is the same. There is this unknown B over here. Find the value of B. AB, that is OB minus OA. OB minus OA. You get this thing. BC, that is OC minus OB. OC minus OB. Be very careful with this. So now the magnitude of AB is coming out to be this. The magnitude of BC is coming out to be this. They both have this B in there. So there is this B over here, there is this B over here. And since the magnitude of this are the same, you equate this with this. Now also let me just do one thing, that is a lot of people are careless about the square root in this sense. They forget or something like that. So that draw the whole square root. And now when we equate and square both sides, so when we square both sides, the square root disappears. And then I'm left with b minus 2 whole square plus 82 minus common 4 plus b whole square. So minus 1 square is positive 1. This is like a plus b whole square. This is like a plus b whole square. Simplify, the quadratic term is good. It cancels out and we get b is equals to negative 1/3. So this is 10 part 1. Let's move on. Now it says A, B, C, D are the vertices of the rhombus. Find the position vector of D. So if it's a rhombus, we know that it has the same length. So now we will use this previous value of B. Got the idea? So this value will be used. So now this is B minus 2, minus 1 and 9. This is DC. Since this AB is the same thing as DC, or AD is the same thing as BC. So I have used AB, that I already know. I have used DC, which is OC minus OD. OD is unknown, leave it as it is. So now let me take negative OD to the other side, that is positive OD. Take this to this side with a negative sign. And now that is the value of B that we found out. And then we simplify and we get OD. And yes, fractions are part of life. You get an answer like this. Then it says calculate angle ABC. Whenever the name is mentioned, make sure you apply the rule of diverging vectors from angle point. Point where angle is made, that is the angle point. It could be both diverging or it could be converging. Doesn't make a difference. But it has to be both. It has to be both. So now I have BA. I think AB was given. Yes, AB was given. That is AB. I flip the signs. That is BA. I'm choosing BC. So BC is given also, or maybe I found it out. So now BC was over here also. So BC was here. And then BA, magnitude, fraction form. Look at the exact working. Look at the exact working. Now BA dot BC, that is BA magnitude, BC magnitude cos theta, that is BA, that is BC, that is magnitude, magnitude. So now the square root and the square root disappears. Why it disappears? Because this is like this, root A equals to A. A power half is A power 1. That is the logic. And then, of course, you have to use the calculator. If someone was interested in decimals, they could have worked with that. I got this answer. It's acceptable in both degrees and radians. So if it's degrees, final answer 1 dp. If it's radians, final answer 3 SF. And then, no, this is for something else. That's already done. I was using this extra paper. And which variant is this? This is variant 35, May, June 2025, variant 35. So I have worked on 4 vectors question. So that's all about it. See you in the next class.